Also, for the chat, please feel free to post your answers and your questions in the chat. But please do not exchange personal information with each other or anything like that. Let's just keep ourselves focused on the task at hand, which is enjoying our maths lesson and learning as much as we can from the experience. And with that said, we are going to start calculus. Can I see, just by giving a thumbs up in the chat, how many of you have actually done calculus in school? Just give me a thumbs up if you have, and if you haven't, just a thumbs down. Okay, so a lot of you have already tackled this big and important topic. Okay, so we've got 4 lessons in this course on calculus. So we are really just going to focus on the beginning part of calculus, which is the first principles, gradient and average gradient, and how to differentiate. So we won't get to really drawing cubic graphs or doing calculus applications, word problems and stuff like that. We are just going to focus on the sort of basic ideas, the key concepts around calculus, and really getting you very good at doing first principles and differentiating. And then at a later stage, we'll make time again to continue with calculus. Right, so if you haven't done it, like I see Muhammad says he hasn't done it, it is really not a problem, because you are just going to have a little bit of a head start with the rest of your class at your school, because you'll get a sneak preview into what calculus is about. So when you hear your teacher do it, then you'll already know and you'll get another chance to practice. And for those of you who have done it, now you get another chance as well. So everyone gets 2 chances basically to hear the content again. Okay, so with that being said, we're just going to start by looking at something that's not tested on its own in the final exam, but it is an important concept for when we are looking at calculus and working especially with the formula for first principles. And that's this idea of a limit. So when we are finding a limit, and maybe for those of you who have done a bit of calculus and you'll think of the first principles formula, you would have seen this notation of the limit as h tends to 0, for instance. You might have seen that. So when we are talking about a limit, we look at what happens to a function value of a curve when we get closer and closer to a specific x value. So what happens to a function value when we get closer and closer to a specific x value on the curve? And just like most things in maths, we have a specific way of writing that in symbols, and that is just saying the limit, and then there's an x with a little arrow pointing towards that x value that you are investigating. Okay, what is happening to your function as your x value tends towards, and that's the words as we say it, the x tends towards c or whatever that value is, like a 5 or a 2, etc. So lim stands for limit, and the notation x with the arrow and the c, that c is your specific x value that your graph is approaching. So it's something very simple, like say I have a function like f of x, and let's just do like a straight line function, 2x plus 5. And I think of an x value that I want to see how does my function behave as it approaches this value, and that can be anything like a 2 or a 3 or a -5. So I will say, what is the limit as I make my x get closer to a -5, for instance? Okay, we're going to see now how to work out that limit. It's quite straightforward, but it's just that idea of as my graph approaches this x value, what is my y value doing? Because if you remember from our lessons last week, Oh, and by the way, those of you who haven't been here before, maybe this is the first time you're attending Watobe, we do have all our lesson recordings available on our website. So head on over to the website and you can watch all of those recordings again. And specifically, as we said last time when we were doing functions, that I have an input value and an output value. So if my x is -5, that's my input value. What is my output value? My y. How is my y behaving as my x tends towards -5 in my example here? Okay. F of x, as we also know from our functions course, f of x represents the function that we are working with. Okay, so let's calculate some limits. And I just want to say again, this is not something that you will get in your exam, like calculate a limit. But the concept of a limit is important for when we're going to use limits when we do calculus first principles specifically. Okay, so this question says, what is the limit of 2x minus 1 as x tends towards 3? So it's all we have to do, and how we approach this question is that we actually substitute x equal to 3 into the function. So substitute x equal to 3 into 2x minus 1. So we can write 2, and I replace my x with a 3 and subtract a 1. That's 6 minus 1 is 5. So the limit as x tends to 3, that is equal to 5. And really all we've worked out, but just looking at it in a slightly different way to what we normally do, is what is my y value if my x value is 3? Okay. Let's look at another example. And sometimes it is not that straightforward. We can't just substitute in to calculate our limit. Because if we're going to substitute in, we are actually going to make the denominator 0. So this especially apply in fractions and where we have algebraic fractions, where there are unknowns in the denominator. So in algebraic fractions. So if I now go and I make x equal to -2, this, if I make that -2, then will be +2, and my denominator will equal 0, which will make everything undefined. So I can't do that. I must think of another plan. So the plan here, if we look closely, we can see that what we've got here is a trinomial. So why don't we try and factorize and see if that doesn't maybe make things a little bit more workable. So the limit as x tends to -2. Okay, and as always, I am expecting you to be taking notes and actively working with me as we are doing all of this, because I'm sure after 12 years of doing maths, you know by now that maths is not a spectator sport. So you've got to jump in and work with us as we go through this. So please factorize that trinomial. And as soon as you have your factors, please pop them in the chat. I'm going to give you a minute or so to factorize that trinomial, and then we are going to see what you put in the chat and carry on working out our limit from there. Anyone got the factors yet? Well done, Mohammed. On your first day, you are popping the factors in the chat for us. That's good stuff. Anyone else? Nakane agrees with Mohammed. X plus 2 and 3x minus 1. 3x minus 1, x plus 2. And I think that is most certainly right. 3x minus 1 and x plus 2. If you switch the brackets around, not a problem as long as the two brackets are 3x minus 1 and x plus 2. So we're going to cancel the x plus 2, and that actually solves the problem of having a zero denominator. So the limit as x tends to minus 2 is 3x minus 1. And now we can sub in x equal to minus 2. And notice that we only drop this limit notation, this whole part here about the limit as x tends to minus 2. We're only going to stop writing that as soon as we substitute our x minus 2 into our expression or our function. So that gives me 3 times minus 2 is minus 6, minus 1 is minus 7. Okay, let's see how well you understood all of that and got the hang of limits. One more example. I'm going to give you a chance to do this on your own and pop the answer in the chat as soon as you are done. Let's say we've got 2 minutes for that. Let's try and be done by 20 past 5. So we'll check back in at 20 past 5. But in the meantime, if you have an answer, just pop it in the chat. Okay, lots of answers coming into the chat. Right, let's see. So we don't have an issue in the denominator, can't factorize, so we can go straight to substitution and make this 1 minus 5 over 1 plus 1, and that is minus 4 over 2. Final answer, minus 2. Well done, everybody. It looks like quite a few of you got that. So you got the whole hang of a limit, and that we just substitute in, and that we're just basically looking at our function and how it behaves as we approach a certain x value with that function. Okay, so that's the one idea we need when we do calculus, and that's, we kind of need to keep that in the back of our heads or in the back of our minds. And the other one that we also know already, and maybe you didn't know it was called this, or maybe it's the first time you hear it being called this or see it being shown like this, but that's the average gradient. And the average gradient really is just something you have been doing for a while, since grade 9 or so, where we had the gradient, which was m, and we said the gradient is the change in y over change in x. We also recently did this when we did functions and analytical geometry and all of that. And the change in y over change in x was y2 minus y1 over x2 minus x1. But for the average gradient, we always use 2 coordinate points. 2 coordinate points, that's why we have y1 and y2 and x1 and x2. So what's written here in the block is just a different way of representing that. So if we have f of x, and we want to find out what the y value is, then we sub in f of x, x2 and f of x1. So what's written here is just another way to represent this formula that I think most of you know by now quite well. Okay, so let's have a look at calculating the average gradient. So here we've got the average gradient of f of x, and we are given our function here that is x squared minus 2x plus 2. And I've got two x values, x is 4 and x is 2. So if we want to calculate average gradient, we need two coordinate points. So that's what we're going to have to do next. If we have the x's, we need the y's. So to get the y's, we will need to sub in each of these x values. So I'm going to start with x equal to 2 and sub that into our equation or our function so that we can determine what the corresponding y value is. So that's for f of 2. And then f of 4, we can calculate that as well so that we can get our corresponding y value when x is equal to 4. Okay, so what have I got here? I've got 2 squared minus 2 minus, that's 2 squared is 4, minus 4 is 0, plus 2 is 2. And here I've got 16 minus 8 is 8, plus 2 is 10. So we can call this x1 and x2, and then this is y1 and y2. And on the side, here's a little picture just representing the situation, just to give us a more graphical idea of what's happening here. If you look at f of x is x squared minus 2x plus 2, then that is most certainly a parabola. And here are my 2 points that I'm working with now, 2 and 2 and 4 and 10. So to calculate average gradient, we are going to take y2 minus y1 over x2 minus x1. And that is 10 minus 2, 10 minus 2. My x value here is 4 minus 2. And that is 8 over 2. And that's a gradient, an average gradient of 4. Okay, so just put a thumbs up in the chat if you are happy with that and following along so far. Just a quick check-in to see how we are doing with this whole idea of the average gradient, which really is just calculating the gradient as you have been doing up to now. Since grade 9, a whole long time, for 3 years, you've been doing average gradient. And today, with the day you learned calculus, the world just changed. And you learned that you can move away. Is that a bit dramatic, Miss Coco?
I mean, it sounds like the world is coming to an end. Now we've moved from y to f of x. So it's okay, guys. It's okay.
But the world is not coming to an end. It's actually just like starting. Okay, everybody. So that's great. Here's another example. Please try this one on your own. We've got the average gradient between point A and B. If these points lie on this function, f of x, there's point A, there's point B, and quickly in 1 minute, calculate the average gradient for me between point A and point B. Put your answer in the chat as soon as you're done. That was really quick, Liam. Really quick. Lightning fast. Also lightning fast, everyone. I haven't even taken a sip of water and these guys are just calculating the gradient so quickly. So minus 40, minus 14 over, just move the chat box so I can see what's going on, minus 4, minus 1. So minus 40 minus 14 is going to be negative 54. And that's going to be minus 4 plus a 1 is going to be minus 3. And 54 divided by minus 3, that's 18. Well done. Okay. Well done, everybody. That gradient is 18 between the two average points. And just one last one. Question B, again, just calculate the average gradient between point A and B.
Oh, ma'am, is that 7.5?
Yes, that is 7.5 and 1.5, yeah.
Okay.
Mohammed's also very quick on his first day here at Watobe, Miss Coco, really on fire. Okay, so I go 14 minus 7.5 over minus 1 minus 1,5. Everyone says it's 13, yes. Okay, let's see. 14 minus 7.5 minus 1 plus 1.5. Yes, I also get 13. Well done, everybody. Okay. Yeah, they were beating me to it as well. I don't know. They might have a trick up their sleeves. Okay, so let's pause now and think about the whole thing with the average gradient. And I'm going to scroll up to this little parabola we had here of minus 2x squared plus 8x plus 25. And I'm just going to go to point A. And I'm going to draw a tangent line there. And I'm going to draw another tangent line here at point B. Okay, and I'm going to go just at another random point, maybe over here. And I'm going to draw another tangent line. And if you're working in your book, and I would like for you to make a quick drawing of this parabola that we have here and draw these tangent lines in as well, because it's quite important for understanding the concept of the derivative. So what we've just done, and let me also then connect point A and B, because this gradient between A, B, we've just calculated that as an average gradient of 18. But if we go to point A and we go to point B, A and B, and we just look at these little tangent lines that I drew here, we can see that the gradient at point A is clearly quite different to the gradient at point B. And if we go here to my random point C, that gradient is also different. So anywhere actually where I go on this graph, so say I make another point, even here, and I draw another tangent line there, then even that one is different. So anywhere I go on this curve, if I imagine starting on this side and walking up this curve, each time as I move, the gradient is going to change. It is never going to stay consistent to this 18 that we calculated. And that's why we say it's an average gradient between 2 points. It is not the instantaneous gradient. The instantaneous gradient is the gradient at a specific point. So if I go to point A and I only want to know what the instantaneous gradient, the gradient specifically at point A is, how will I work that out? How will I know that? Because currently the tool that we have at our disposal is one where we need 2 coordinate points. So our gradient formula, this one that we use over here, we always need 2 coordinate points. For all of these calculations, we use 2 coordinate points. So if we only want to use 1 coordinate point and calculate what the gradient at that specific point is, that's when we're going to use the derivative and calculus to do that for us. And we're going to start off by just looking at a formula that is called first principles. Okay, so the derivative from first principles. Now, first principles just mean that this is like the basic idea that it was Isaac Newton that invented calculus, yeah? So when he first thought of calculus and this idea of a gradient of a tangent at a specific point, this was his idea and this is the formula he used. Now, this formula is on your formula sheet that you get with your grade 12 exam. Okay, so if you do have one there with you, then you can maybe look it up and see where it is. And basically what it says is that if h tends to 0, so here's where the limit part comes in. So the limit as h tends to 0 means that if I have 2 coordinate points and I move them closer and closer together so that the distance between them is almost 0, I can use that to calculate the instantaneous gradient. Okay, now if you've done calculus at school, you'll know that you have this way of calculating the derivative, which is a long way and it gets quite a lot of work. But there's also, luckily for us, a short way. So you will get at least one question where you have to calculate the derivative using this formula of f dash x is the limit as h tends to 0, etc., etc. So you will get one question like that, so you got to know how to do it. Okay, and it is actually, if you work closely and accurately, it's 3 marks. But for the rest of the time, we're not going to bother with the formula. We're going to do the short method, which you should know if you've done calculus already. You should know the differentiation rules or the short method. Okay, so right now, that's a mouthful. I just want you to be very clear about what the derivative is. The derivative is the gradient at a specific point on a curve. And you can write this down or take a screenshot. Definitely welcome to take a screenshot. Then it's at a particular point. It also involves, you know, if you think back to these little tangent lines that I drew here on our parabola. So it is the gradient of that tangent line to that curve, and it has to do with the instantaneous rate of change. For those of you in the house who also do physics, you can, once you know calculus, I'm quite sure, Ms. Coco, help me here because physics is not my subject, but you can use calculus to do physics problems as well. Hey?
Yeah, by the time you get to first year, physics and maths are the same thing, so yeah.
Oh, wow. Okay. Okay, so we're going to visit the short method rules in our next lesson. So we're going to just for today get through this long method first principles rule that we use. And we're going to start off just slowly with one of these. This first one over here, f of x is 5x. Okay, so the question says determine f dash x. So that's how you say it, f dash x. So we've all been seeing f of x, that's function notation. So now with that little dash with it, that indicates that we are finding the derivative from first principles. So only use this formula when you are doing first principles, not just when they say differentiate, only when you are told do you use this. Okay, so our f of x is 5x. Let's write down our formula, and be so careful, guys, when you copy down your formula from your formula sheet, that you do so correctly. So often I've marked matric papers and then the formula is wrong. People copy it incorrectly from the formula sheet, and I actually feel so sad for people, because then everything is wrong, unfortunately. So work accurately, precisely, copy down correctly, double check. Okay, that looks right to me. So I'm going to also try and guide you through this so that you find ways of working a bit easier with this formula, and so that it's not such a mess with too much stuff happening. So what I recommend you do is you first do a bit of working out before you put everything into the formula. So we've got our f of x, we've got it here. So this is f of x. That's the same as this f of x over here in the formula. So the next one we're going to do is f of x plus h. Now, f of x plus h just means replace x in our expression, in our function, replace that with an x plus h. Like that. Okay, so where we see an x in our function, we replace it with a x plus h. And that you're going to multiply out. 5x plus 5h. And that simplified and multiplied out version, you're going to substitute in here. Okay, it helps to keep things a little bit shorter, a little bit less writing, a little bit less of a mess. Because if you've worked with this first principles formula, you know that it can get messy. So I'm going to take my f of x plus h, which is this blue part, and I'm going to put that in there, 5x plus 5h minus, and don't forget to put a bracket around what your f of x is. Because right now it's fine, it's just 5x. But what if it is, oh my gosh, look at this, screen's jumping around. Sorry about that. What if it's something like what we've got in question 3, 2x squared minus 3x minus 5? If you're going to substitute that in, it's going to change the sign. So that's why we need to put a minus around our f of x. Okay, but we can see that the 5x and this 5x, those are going to add up to 0. So we have the limit as h tends to 0. 5x minus 5x is 0x. We have 5h divided by h. And this is a very simple sort of introductory example. And it just so happens that these h's can cancel out. So no more h. So no more need for the limit as h tends to 0. We can just write our final answer, and that is 5. Okay. And once you know the short method, you can use it to check that you've done your first principles correctly. Right. Let's see another round of emojis in the chat. How are we finding this formula for first principles? Just with this sort of gentle introduction of this, the derivative of 5x. Nice. We've got some thumbs up. Okay, so then we are ready for number 2. And I'm going to leave you alone for a little while with number 2. See if you guys can find the derivative using first principles. The question is f of x is 3x squared. Well done, everybody. I see thumbs up. That's great stuff. So we are going to find the derivative from first principles, in other words, using the formula or the definition to find the derivative of 3x squared. Okay, we'll check back. This is normally a 5-mark question, so we'll check back at about 1:45 how everyone is doing. And if this time around you put your answer too quickly in the chat, I know you're cheating. Okay, guys, just remember we are using, answers are coming in quick, so just make sure you've used first principles to do this one, hey? Galaxy A12, not sure what your name is. Maybe you can change your name for us so we can not address you as a phone. Maybe just clarify, what do you mean? Can I use the derivative on my f of x? Not sure what that means. Make sure you've used the first principles, please, everybody. No cheating. Okay, so we are going to substitute in x plus h. And again, before you get to the formula, just do this working out first. And x plus h means we are multiplying x plus h with x plus h. So it's not x squared plus h squared, it's x squared plus 2xh plus h squared. And then we're going to put the 3 into the bracket. So 3x squared plus 6xh plus 3h squared. Okay, now we can't go further, so we can go to our formula and write f dash x, or the derivative of f, is the limit as h tends to 0 of f of x plus h minus f of x over h. Okay. So as I'm doing this, please check that you've done this correctly and that you've done all the steps accordingly. Dropping the limit as h tends to 0 before the end will get you penalized quite heavily at the end of the year. Okay, so don't do that. Just write the limit as h tends to 0 each time. Don't be lazy. Just write it each time. So 3x squared is the f of x plus h. So I'm going to replace f of x plus h with 3x squared plus xh plus 3h squared. And we're going to subtract from that 3x squared over an h. Okay, so then the limit as h tends to 0, our 3x squared is going to add up to 0 with minus 3x squared. So we're going to have left 6xh plus 3h squared over h. And here we are going to take out a highest common factor just of h. I know we can take out a 3h, but let's just take out an h, because what we want to do is just eliminate this denominator that we have here. So the limit as h tends to 0, take out an h as a common factor, 6h plus 3h. 6x plus 3h over h. And then that happens. Okay, and the only thing left to do is to replace our h with our 0, because that's our limit, right? Remember a little bit earlier on in the lesson, as we were just working out limits, we make the h equal to the 0. And at the point where we do that, we can drop the limit as h tends to 0. So this is going to be 6x plus 3 times 0, which is 6x. Okay. So make sure you've done everything accordingly. You didn't drop your limit notation, and you only dropped it here at the end where you made h equal to 0. Check for all those little things. And if you got all of that right, you can give yourself a great big smiley face for getting full marks for that. Okay, we're going to step it up a little bit and do this last one. 2x squared. Rachel, you got a smiley face, happy face, well done. We're going to do this last one, also using the formula. Now be careful, the others were a little bit easier, but this one might get quite long, okay? So I'm going to leave you alone again for about 4 or 5 minutes. And let's see how you go with first principles. And if you all get this right in the exam, I'll just be so ecstatic. Liam, I hope you've used the formula. You must use the formula. Must use the formula to get this answer. I think you guys maybe went a little bit too quick. Definitely check your answer, Liam. Jimmy, you too. Just check again. Just go back. So Piso, it looks good, but I hope you use the formula, first principles, not short method, just first principles. Okay, I'm not believing that everyone everyone used first principles here, because this question's way too long to have finished so quickly. So if you haven't used first principles, yeah, guys, you won't get marks in the exam if you get asked to use first principles and then you don't. Okay, so make sure you follow the instructions of the question. This one is just way too long and messy for some of you to have finished it that quickly. So it's fine if you do it here. I mean, there's not much I can do about it, but make sure that you follow the instructions carefully. Okay, so we replace our x with x plus h first and do that little bit on the side here. Remember, you do get marks for this, so just do it on the side. Don't do it in pencil or anything. You do get marks for this. It's just to kind of keep the whole formula part a little bit simpler. I'm very glad that you guys, Twenga and Tepiso, good. I'm glad you used first principles. That's what you were meant to do. So let's put into our f of x plus h, this answer that we worked out here in blue. So that's 4xh plus 2h squared minus 3x minus 3h minus 5. Look, if you used first principles and you nailed it, then well done. I'm really proud of you for doing that. Okay, now our f of x is over here. Let me just scroll up a little bit. Okay, I'm going to do that in pink so that we can keep track of what we are putting where. So that is my f of x. So I'm going to subtract it. So minus 2x squared minus 3x minus 5. Put a bracket around it. Minus 3x minus 5. And then all of that stuff must be over h. It's a lovely straight line I'm drawing there. Okay, right, we're going to subtract all of this here. So that's going to go 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus 5 minus 2x squared plus 3x plus 5. Okay, and in doing that, we get rid of the 2x squared and the minus 2x squared. Let me not forget my over h. And we're going to get rid of the minus 3x and the plus 3x and the minus 5 and the plus 5. What about my minus? Are you joking about my minus? Oh, the minus, yeah, you see, put a bracket. Put a bracket, it messes your whole thing up. I thought I might have made a skew minus, where someone's laughing at my very straight line that I'm drawing here. Anyway, what have we got left? We've got 4xh. This is like a Jane Austen novel we're reading here. It just goes on forever. Over h. Whew, okay. It's getting a little bit shorter now.
No, I didn't know Jane Austen novels were too long. It's the first time hearing this.
I don't know. I find them too long. Which one is a Jane Eyre? I think that's like this long. It's like this thick. So, too long. This is like Jane Eyre.
Well, luckily for us, maths gets shorter. So yeah.
Yeah, no, to the point. Okay, so at this point, we take out a highest common factor of h, just an h. 4x plus 2h minus 3 over h. That gets rid of my h in the denominator. And in my last step, I'm going to replace my h with a 0. So we drop the limit notation. And our final answer is 4x minus 3. And I know that those who finished it in a minute didn't go through all this pain. And those of you who did, yay, well done. Super proud of you. And we are right on time. Well done, everybody. That's first principles. Just one in the exam. And please only do it when you are told to. Do not do this voluntarily. Okay, over to you, Ms. Coke.